Welcome to the night class one more time. Today we're still graphing sine and cosine, but we're doing just a little more complicated equations. Fun times that everyone is going to have. All right, there's our problems we're going to do. Where is our notes? There we go. Boom. All right. Everybody read? It's a little big, huh? Need to make that a little smaller. Let me see if I can do that. Let's try that. Hey, that's better. All right. So, yesterday we graphed them. See how much we remember. Today we're talking about the amplitude and period. What was the period yesterday?
How long it takes to make one wave.
One full wavelength. And how long was that for it when it's just y equals sine theta, y equals cosine theta? It was 2 pi. And why was it 2 pi? That's a whole circle, right? One full circle. So, today we're going to be changing that period a little bit, which basically means we're going to take the wavelength and we're either going to compress it in or we're going to stretch it out to where it's longer, okay? The amplitude is basically how high it goes or how low it goes from the midline. Like yesterday, our midline was the x-axis every time, okay? So yesterday's amplitude was 1 because it went up. 1 was the highest it would go. -1 was the lowest it would go, okay? So these first few little equations here, to do the amplitude, it's just the number that's in front of your sine or cosine, okay? The amplitude is a distance, therefore it's always positive, okay? So even if it says -3 sine theta, your amplitude is 3. Is that making sense? Okay? If it's 5 sine theta, your amplitude's 5. All right? And so yesterday when we made our little table, or our graph, our coordinate plane, we went up to 1 and -1. Well, now if it says -3, we're going to go up to 3 and down to -3. Easy enough? Okay? The period you get from whatever number is in front of the theta. Now, that's not the period, okay? The period is not k. The period is actually equal to 2 pi divided by k, all right? So you have to do a little figuring. The amplitude, you can just look at it and know. The period, you have to do a little math, okay? So let's try a few, and we'll have fun for the day. It doesn't tell you on any of these, but I'm telling you now, we're going to graph. When we graph them, we're going to do 2 periods worth, so you can kind of see it. Okay, yesterday we just did 1 period. Okay, today we're going to do 2. So it says, state the amplitude and period of each function, then graph each function. All right, so like I said earlier, the amplitude is easy. What is the amplitude? 10. Right there, it's just that number in front. Okay, my period is 2 pi divided by k. What is k in number 8?
20.
That's not 20. That's a 2. Okay, 2 theta. The k is whatever's in front of the angle. Okay, so 2 theta. So 2 pi divided by 2 is pi. Okay, the 2's just canceled. So what did that mean for my graph? We just took everything that we were doing in 2 pi and shrunk it down. Now it's going to go through 1 full wavelength in half that time, and for just pi. Okay, so like I said yesterday, the graph technically isn't going to look any different. The only thing that will be different is our labels. Okay, so I'm going to do, we'll always go the positive direction here. So again, I'm going to do how many periods worth? 2. I'm going to do 2 periods worth. So what's the highest and lowest it goes to? Positive 10 and negative 10. Yesterday we broke it into 4 parts. since we're doing 2 periods worth, we're going to break it into what? 8 parts. So, boom, 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 boom. Okay? You just keep halving it. So, I know 1 full period is pi. Okay? Here's how you count. Okay? Yesterday it was always 2 pi, and then you'd have pi over 2. Right? You're counting by pi over 2. So, why was it pi over 2? What did we divide the period into?
Teacher, sorry for the interruption, but I just wanted to let you know if you were not able to meet with Taylor and Sons yesterday, they are here again today in the library.
Insurance people. All right, what did we divide the period into yesterday? Think quadrants. There's 4 quadrants, so we divided into fourths. Remember? We had pi over 2, and then pi, and then 3 pi over 2, and then 2 pi, basically. Okay? So we're still doing that. We're going to divide our period into fourths. So if I take my period, which is what? Pi, and I divide it by 4, that's what I count by. Okay? So what is pi over 4? No, just say what I just said. It's pi over 4. So this one's going to be pi over 4. What would the next one be? Nope, you're counting. This was 1 pi over 4. The next one would be 2 pi over 4, which is pi over 2. Okay, the next one would be 3 pi over 4. Does that reduce? No. And then the next one would be 4 pi over 4, which is just pi. Okay, that's 1 period worth. Everybody with me? Okay. What would the next one be? 5 pi over 4. The next one would be 6 pi over 4, which reduces 3 pi over 2. Then 7 pi over 4. And last but not least, 8 pi over 4, which is 2 pi. 2 periods worth. That makes sense? Okay? Now, today's is actually even easier to graph. You just got to remember the pattern, okay? We're doing sine. So do y'all remember, does it cross the y-axis at 0 or at the maximum?
0.
It was 0. So that's where my first point's going to be. And watch, this is kind of even, I'm kind of embarrassed to even teach it like this, but this is how I do it. Do y'all remember, after the first one, did we go up or did we go down? We went up. It went up to a maximum, right? Now, how could that switch? How could it go down? What would be negative to make it go down? The 10. Okay? If it was negative 10, I would go down first. But it's positive 10, so I'm going to go up first. And then I'll be back in the middle. And then I'll go down to the bottom. And then I'll be back to the middle. And you just keep doing that all the way down. Does that make sense? Okay? So at 5 pi over 4, I'm up here at a maximum. 3 pi over 2, I'm back in touching the x-axis. 7 pi over 4, I'm down here at a minimum. 2 pi, I'm back on the line. And then you just draw your beautiful little wavelength. Okay, I missed it. Okay. That's pretty bad at the bottom. I'm not going to let it bother me that much. I am. I can't help it. I'm sorry. Maybe I'm not. Oh, it erases the whole thing. Let's try this one more time. Oh, that's much better.
Mine looks a little pointy.
Any questions? Had it said cosine, where would I have started? At the 10. And then I would go, on my next point, I'd be on the line, below the line, on the line, above the line, below the, you see what I'm saying? It's just a pattern. So really, you just got to remember, where do I start? Cosine, I start either there or there. Sine, I start at the origin.
And if it's negative, you start.
If it's negative and I'm starting at the origin, I go down first.
And then you go
If it's
up.
negative and it's cosine, I start at the bottom rather than starting at the top.
Okay.
Does that make sense? If it was negative 10 cosine,
Right.
I would have started, rather than starting at 10, I would have started at negative 10.
I got it.
Everybody see the pattern? Again, has the graph changed? No, the graph doesn't change. The only thing that's changing are our labels. Everybody got that? Okay? But basically the graph stays the same every time. All right? 9. Oops, went too far. What's my amplitude on number 9? 3. And my that's 13. Sorry. There we go. So my amplitude is 3, and my period will be 2 pi over, what is k again? 2. So that is just pi again. So it will look very much just like the one we just did. See here, half that up, half the halves, and then half it one more time. That's all I'm doing. What am I going to label the top up here? 3. And the bottom would be -3. Okay? And this is again pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4. If your period is pi, yes. But guess what? Your period will not always be pi. Okay? So, the correct answer to your question is no. It will not always be these numbers. All right, so we're doing cosine. So where are we going to start at? The origin or the max or min? The max. And it is the max because the 3 is what kind of 3? Positive 3. So I start at the top. My next one, I'm at the x-intercept. The next one, I'm down at the bottom. And you just, again, you just keep doing the same pattern. Cool little roller coaster there. Any questions? Everybody good? Everybody can graph that? Not too bad? It's a good lesson for a Friday.
That's it.
Well,
All right.
close. 12 and 13, I know the directions aren't in there because they're in your book, but they give us the amplitude and period, and they want us to write the equation. Okay? So, we're going to say for 12 and 13, let me look and see. 12 and 13, it says for sine. Okay? 12 and 13 is sine. So we're going to write the equation for sine. It's not hard at all. We'd only know 2 things. We need to know A, and we need to know what? Not B. Good try. What was that letter we looked for? K. Okay? We need to know A, and we need to know K. A is easy, because A is the what? Amplitude. Okay, so I know right now my equation is y equals plus or minus 0.8. Now, why am I putting plus or minus? Because it could be either or. Okay? All right, remember, your amplitude's always positive, but in the equation, it might be negative. Okay? So plus or minus 0.8 sine of, we got to figure out K. Okay? So, they gave me the period. It's pi, and I know the period equals 2 pi over what? Over K. And I solved that for K. Okay? So what can I do with the pi and the K? I can swap them. K will be 2 pi divided by pi. So K is 2. So I put 2 there. All there is to it. Okay?
How do you know it was on?
Look, I read the directions. It tells you in the directions. I should have put the directions up here, but I did. On the directions it says write an equation of the sine function for each amplitude and period. Okay, the next directions say write an equation for the cosine function for each amplitude and period. Okay, so yeah, it's in the directions. Yeah, there. I wrote these. Don't know why I didn't on the other one. All right, here amplitude is 7, so plus or minus 7 sine of pi over 3 equals 2 pi over k. I'm actually going to just cross multiply on this one, okay? Pi times k is pi k or k pi, however you want to say it. 3 times 2 pi is 6 pi, and I divide by what? To get k by itself. Divide by pi. K is 6, so 6 theta. Okay? Any questions? We got 2 more, exactly the same thing. The only difference is instead of writing sine, you're going to write what? Cosine.
Why'd you put plus or minus in front of it?
Because it telling you the amplitude is 10, or in this case 7, doesn't mean it has to be positive.
Oh, because.
In the equation, it can be either or.
Right.
And you don't know, so you need to put both. Okay? All right, 15 and 14. Again, same thing. This time we're doing cosine. So y equals plus or minus 1.5. Cosine, let's figure it out. 5 pi, our period, equals 2 pi over k. On this one, I can just switch them, okay? K will be 2 pi divided by 5 pi. The pi's cancel, and so what is k? 2 over 5 times theta. You could also write that 2 theta over 5 if you wanted to. All right. And last but not least, y equals plus or minus 3/4. My amplitude, cosine of, let's see here, 6 equals 2 pi over k. Switch your k and your 6. 2 pi over 6 reduces to pi over 3. And it is okay to have pi over 3 in your equation. Everybody good? Easy peasy? Okay. So understand, all we've done, basically, if you didn't realize it, we're doing transformations, right? Okay, so the period is stretching or shrinking, okay? So we're pulling the wavelength or we're scrunching it in, and it's going a little higher or going a little shorter than normal, okay? So tomorrow, well, Monday, we will do the translating. We'll like actually shift it over to the right or shift it up and down or shift it left, okay? All right. Hope this video helps. Y'all have a great day. See you next time. Stay above that line.